Alright guys, today we're going to talk about application of trigonometry. Yesterday or the day before, or depending on when the snow day is, or if you're sick, the last lesson we had, we talked about SOHCAHTOA, and that was with sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. Today we're going to talk about applications of that, i.e., probably some word problems, some pictures, and the like. The first thing you have on your lesson, though, is the bell work. So we're going to go through that first. So it starts off that we have a triangle RST where the measure of angle T is 90 degrees. So usually I'll just stop right there, and I'll say, well, that means I have a 90-degree triangle. Let's make that a little better, 90 degrees. And we'll make our 90 degree here, and it says that that must be angle T. Now the other ones can be R or S, doesn't matter where you put them, so I'll put the R up here, I'll put the S down here. So now we have RST where T is 90 degrees. Then it says that RT is 11 centimeters, let's just put 11 by RT, and it says that RS is going to be 28. Then it says, what is the measure of angle R? So angle R is this angle up here. So I'm talking about this angle here, and what I'm going to look at is what information was given to me. Well, the opposite side to angle R would be TS. Well, I don't know anything about TS. Then we'll look over here and we have angle 11. Well, that's our adjacent side. And then we also know the hypotenuse is 28. So that means I know the adjacent and the hypotenuse. So I have to do my SOHCAHTOA to come up with the fact that, well, the cosine of an angle is going to equal the adjacent over the hypotenuse. In this case, I don't know the angle value, so we'll just call it cosine R is going to equal our adjacent, which is 11, over 28. Well, to get my or that R by itself, we need to get rid of that cosine, which I would take the cosine inverse of both sides, which makes sense because I'm looking for an angle. I'm looking for that angle R, and to find an angle, you have to use inverse. So when I take the inverse of both sides, you should wind up with basically R is going to equal the cosine inverse of the adjacent over the hypotenuse. Remember, inverse takes whatever side you're looking at and pops out an angle. So in this case, it's cosine of the adjacent over the hypotenuse is going to give me my angle. Now, if we plug that in our calculator, we're going to come up with R is about 67 degrees. All right, before we get into the word problems, we're going to have two new words that we have to look at. Well, really just one new word, and that is the angle elevation / depression. But there's a difference between angle of elevation and angle of depression. So the first one we're going to talk about is angle of elevation. To me, elevation means how high something up. So it is moving up. So if we read this explanation, it says angle of elevation. The angle formed by the horizontal line and an observer's line of sight to an object above the horizontal. So if we look at the little picture of that guy, when he looks up at something, so right here, that is our angle of elevation. Basically that angle from looking straight ahead to moving up, how much he had to move his head. Now, you can look up at something, and you can also look down at something. So when you're looking down at something, that is going to be our angle of depression. That is the angle formed by the horizontal line and an observer's line of sight to an object below the horizontal line. So in this case, me looking downwards is going to be my angle of depression. That angle from keeping my head neutral to looking down would be the angle of depression. Now, depending on what object we're talking about is going to be basically whether you're going to know it's an elevation or a depression. So in this little picture here, we have a lighthouse. We have a lighthouse that has an angle of depression of 35 degrees because we're looking from where if the lighthouse could look straight up to its angle down. So that is our angle of elevation, or depression, I should say. However, if I'm talking about this boat, that upward motion from kind of that horizontal would be an elevation. So the interesting thing about a depression and angle of elevation in cases like this is they're both equal to each other, because if you look at that 35 and 35, those are alternate interior angles because both of our horizontals are parallel to each other. So if you look at that, both those lines are parallel to each other, so these are alternate interior. So if I just happen to know the angle of depression of the lighthouse, if I would have a word problem that says the angle of depression of the lighthouse is 35 degrees to a boat, then you'd also know that angle of elevation from the boat to the lighthouse would also be 35 degrees. So both angles are congruent because they are in fact alternate interior angles. Once again, that's important because there will be times where you're just given one of those and you actually have to apply it to another direction on the drawing. All right, this example. So we have a macro trains pigeons on the roof of his building. Classify each angle as an angle of elevation or an angle of depression. Note, measure of angle 1 equals 45 degrees and measure of angle 2 equals 30 degrees. What are the other measures? So first of all, let's talk about angle 1. Well, angle 1 they told me was 45 degrees. So I'm going to draw on the picture. And then we're going to state angle 1 is an angle of elevation. Because that's the angle of Marco standing on his dangerously close to the edge, it looks like, roof. That would be his angle looking up at that particular pigeon. So that one is 45 degrees and it's an angle of elevation. I guess we should also put measure of angle 1 equals 45 degrees because we are going to list all the other ones. All right, angle 2 on the other hand, well, that's 30 degrees. But this time he is looking down at one of his pigeons that are flying kind of below the roof line. So angle 2 is depression. And the measure of angle 2 equaled 30 degrees because that is what they gave us. All right, 3 and 4, they didn't give those measures, so we have to come up with them on our own. If you look at angle 3 is kind of that angle that is that bird looking down at Marco. It goes from the horizontal downward. So angle 3 is depression. And not only is it depression, we actually know the measure of it. If we look at angle 3 and angle 1, those are alternate interiors. So angle 3 and angle 1 must be the same measure. So the measure of angle 3 must equal measure of angle 1, which equals 45 degrees. Likewise, angle 4, that is that bird looking up at Marco. Marco's looking down at the bird is looking up, so we have an angle of depression and an angle of elevation. This will be our angle of elevation. And that would be the measure of angle 4 equals, now if you look at that angle of elevation, that is an alternate interior to angle 2. So angle 4 is going to be the same measure of angle 2. So this is going to be 30 degrees. So that's basically long and short how elevation and depression work with angles and being able to go from angle of elevation to depression and knowing that they're both the same. All right, we're just going to do 2 examples and then we'll be done. All right, example 1 says the angle of elevation from boat to the edge of a cliff is 38 degrees. If point A is 80 feet from the base of the cliff, how high is the cliff? Well, point A is actually where the boat is. That's what that point A is. So this is the boat's location. So in short, it says that point A is 80 feet from the base of the cliff. That means the boat is 80 feet from the base. So that will take care of that A. So first of all, we have this boat, this beautiful boat that's going to be drawn right now, right there. It's floating across some water. And then we have some cliff. We have some cliff that's 80 feet away from it. So here will be my cliff. Let's go ahead and erase all this extra water. We don't need to see that. So we have this cliff here. Now we know that the boat is 80 feet away from this cliff. So let's go ahead and mark that. This is 80 feet from that cliff. It also says that has the angle of elevation from the boat to the edge of the cliff is 38 degrees. So if I was a guy in the boat looking up, I'd be looking up at 38 degrees. Remember, elevation is the one that would be going up like this. So now we have a triangle that happens to be a right triangle. We're going to say it's a perfectly straight up and down cliff that has an angle of elevation of 38 degrees and a base of 80. Well, we're trying to figure out how high is this actual cliff. So let's call this X. Well, now we have one side known, we have an angle known, and we have an unknown side. That means we can actually use one of our trig functions. Remember, we're going to think back and we're going to think of SOHCAHTOA. Maybe I'll write that down. So we have SOHCAHTOA. And TOA. And that stands for sine is opposite over hypotenuse, cosine adjacent over hypotenuse, and tangent opposite over adjacent. Well, if we look carefully at our drawing, we don't know anything about our hypotenuse. We don't know this length, so we don't know this length here. So that means we're not going to use sine, we're not going to use cosine, so we're going to have to use tangent. And tangent is the tangent of an angle equals the opposite over the adjacent. So tangent of that 38 degrees is going to equal the opposite. Remember, the opposite is the one that's straight across. That is going to be our x over our adjacent. Our adjacent is the one that actually touches that angle, so that's going to be that 80. Now we have to multiply both sides by 80, so this would be times 80. So our 80s would cancel out, and this would be times 80 as well. So we're going to end up having just x by itself is going to equal 80 times the tangent of 38 degrees. Now if we plug that in our calculator, we're going to get out about 62.5 feet. So the cliff is about 62.5 feet rounded to the nearest tenth. We don't have any directions of what we need to round stuff to. You will have directions in your homework, but right now we don't. So I always say if you don't have directions exactly how to round it to the 10th. Be safe. All right, the last example we're going to do is it says you measure the angle of elevation from your eye level, which is 5 feet off the ground. That's important. Don't forget about this. To the top of a light post to be 35 degrees. If you are standing exactly 20 feet away from the light post, what is its height? I.e., what is the lamp post's height? So let's go ahead and draw you. And you are a stick figure. So this is, in fact, you. And we have a light post. So let's go ahead and make a light post. Here's a light. And it's a post. And it's light, so it's got shiny light. All right, so that's a light post. And right now you are looking up at it. Now, with that, that must be an angle of elevation, because if you can see your eyesight straight to up would be an angle of elevation. And it says that this is 35 degrees. All right, it also says that you are exactly 20 feet away from it. So if the distance from you to the light post is 20 feet, that means this distance on our triangle is also 20 feet. How far away you are is how far away your eyes are. Well, this is just like that other problem we have just above. I have an angle, I have a right triangle, I have the adjacent angle, and I have the opposite angle is what I'm looking for. So we're going to do the exact same thing we did on the other one. We're going to say, well, this is tangent because I don't know the hypotenuse. So we're going to do tangent of 35 degrees is going to equal x over 20. Once again, tangent is opposite over adjacent. The one opposite is the one you can draw a straight line to, so that would be our x. Our adjacent is the one that's touching our angle. In other words, you have to make like a little half circle to get to our quarter circle, I should say. All right, this once again, you'd multiply both sides by 20, and you'd have x equals 20 times tangent of 35 degrees. Now your calculator is going to spit out about 14 feet. But we have to be smart here. That 14 is just the height of that x. We have to account for all of this space here. And just a quick reminder, that's why I circled that 5 feet off the ground. So we have to add actually 5 feet to this because your eye level is 5 feet off the ground. So we have 5 feet plus that x. So the actual height of the lamp is going to equal 14 plus that additional 5 feet, which is going to equal 19 feet. So take your time on these problems. The rest are just word problems. If you look at the quick thing right here in our worksheet 8.7, it does say round answers to the nearest hundredths place, unless otherwise stated. Also, I do want to notice everything will be posted online, but the answer key is right on the bottom of the last page. That has all the answers on it, so you don't necessarily have to go online if you get them all correct. All right, guys, good luck on this worksheet. We will be working on it in class. So this was your homework if it was in fact a snow day. Worksheet 8.7 you will work on in class either Thursday or Friday if Thursday's canceled. All right, guys, stay warm.